Good day, grade 12s. Welcome to Technical Mathematics. Today's lesson is going to be focusing on functions. As you know that you are heading to the final exam, let us make sure that we touch everything that we have learned, especially from lower grades 10, 11, and grade 12 as well. So it's very, very important to revise what we have learned. And then it's much better if we can use the previous question paper to prepare ourselves. All right. And then the other issue is the examination guideline is very important as well. Make sure that you get the examination guideline just to go through that document and then check what you have to know, especially for functions, what things need to be revised before you go and write your final exam. Very important. Now let's start our lesson and see what are we going to be discussing for this function. Let's proceed. All right, under content, as you can see that we're having functions. Remember, this is a paper 1 topic, and then it contributes 35 plus or minus 3 marks for paper 1. And then under functions, we are going to be looking at linear function. Then we went to quadratic function, which is parabola, hyperbolic function, exponential functions, circle and semicircle, and mixed algebraic functions. So it's very, very important, my dear learners, that you revise every function that you see in the screen, and then make sure that you understand all these parameters such as A, P, Q for quadratic, and then hyperbolic A, Q, and then exponential as well, which is A, B, and Q. So it's very, very important to revise such things. Now let's start and see what are we going to be solving for today's lesson. All right, let me just take my pen. Just want to explain something to you. Use that pen. All right. The introduction, the concept to master in functions. 1, understand the effect of the following parameters. For exponential, we have B and Q. Now, I'm just going to try to explain the issue around B. They are saying if B is greater 1, I'm going to start with this one. They are saying the graph of exponential is going to cut the y-axis at 1, and that is going to be the shape of the exponential function. Only if B is greater 1. And then if B is between 0 and 1. If B is between 0 and 1, what is going to happen with the graph? It's still going to cut y-axis at 1, and then this is going to be the shape of the exponential graph. Now it's going to reflect across the y-axis. So it's a reflection across the line. It is the line y-axis. The line y-axis. All right. So that is the effect of B. So every time when you have the B, especially when it's a fraction, 1/2, 1/3, you know that that number, if you turn it into decimal, it is going to be between 0 and 1. And then we are done with B. And then we have to talk about what? Q. They are saying Q is the vertical shifting. It's either the graph is going up or the graph is going down. So if it's going down, it's going to be minus. If it's going up, it's going to be positive. And then again, Q determines the horizontal asymptote. If Q determine horizontal asymptote, for instance, if if Q it was -1, then you will see there's -1 there. You will see a broken line like this one that represent what? Asymptote. So if Q is -1, then you have to plot that asymptote on the graph by showing with the broken lines. So that is the effect of that Q. And then let's come to hyperbola, and then let's talk about the value of A there. They are saying if the value of A is greater 0, and then what is going to happen if A is greater 0? Then the two curve is going to be on what? On the first and the third quadrant. Only if A is what? Is positive. Then what is happening if A is becoming less than 0, is negative? Then they're saying if that is the case, then hyperbola is going to be on the second and the fourth quadrant, right? And then what about the value of Q? They are saying Q is a vertical shifting. If it's positive, then the graph is going to move upwards. If it's negative, the graph is going to move downwards. Then again, Q, it does it determines the horizontal asymptote. It determines horizontal asymptote. So this is going to be what? Your Q. So if, for instance, if Q is -2, then you are going to see -2, a line which is moving horizontal that cuts y-axis at -2, and it will show with broken lines to show that that is what is asymptote. And then we come to the parabola, value of A. They are saying if A is greater 0, what's going to happen with the graph of what? Of parabola. If A is positive, the graph is going to face upwards. And then now if A is less than 0, meaning if A is negative, what is happening with the parabola graph? They are saying the graph is going to face downwards. So that is the effect of A on the graph. And then what about P? They are saying P is horizontal shifting. It's either the graph is moving to the left or the graph is moving to the right. That is the effect of P. And again, P is what is the value of X on the turning point. But now, this one of P, if you take it from the equation, you can see it's positive P. When you take it to the point, there's going to be negative P. These two. And then, what about Q? They are saying Q is vertical shifting. It's either the graph is going up or it's going down. Again, Q is what? The value of Y for turning point. So this is going to be what? Q. But Q, you are going to take it as it is with the sign. But now the only difference is this one of P. If it's negative from the equation, then it's going to be positive to the point. If it's positive from this, it's going to be negative there. So please make sure that you follow that. All right, now let's proceed. All right, the concept to master in functions. Let's see, sketching. Sketching is very, very important, my dear learners. You must be able to know how to sketch exponential, hyperbola, parabola, a straight line. So it's very, very important to sketch. But you will only be able to sketch the graph if we can be able to find what the x and y intersect. That's first step. That is first step. And then if it's parabola, you must be able to determine the turning point. All right. If it's exponential or hyperbola, you must be able to determine asymptotes. That is very important. All right. But now, later at the later stage, we are going to learn on how to plot the graph. We are going to be plotting the graph today. finding the equation of the function if the sketch is given. Now, if you are given the sketch, all right, and then how do we determine the equation of that function? All right, so you'll be learning that as well today, and then understanding the concept of asymptotes and ends of symmetry. You should know which graph does have asymptotes and which graph does have ends of symmetry. It's also important. And then how do we determine such things? And then domain and range. You must be able to determine the domain of all functions that we have, the range of all the functions that we have. Interpretation of the graph is also important. You must be able to interpret the graph. All right. So that is what are we going to be discussing for today's lesson. All right. The graph of function defined by f of x equals to ax squared plus bx negative 12 intersect the x-axis at negative 2 and positive 6. Show by means of calculation that a equals to 1 and b equals to negative 4. You can see this one. So it's very clear from this question that we don't have an equation of this graph. And you can see it's a parabola graph because it's a quadratic. You can see with the x squared. So what we have, since we don't have a equation, we will have only the x-intercept, because we are told that the intercept of x is this line. This graph cuts x-axis at negative 2 and positive 6. So we have only what? The x-intercept, right? And then you can see the last value there is what? Is our y-intercept. So we have y-intercept. Now, how are we going to solve this question now? Then we are going to use this method. And remember this method, if we are in need of the equation of a graph, and then we are having x-intercept, then we are going to use this method of determining the equation of the graph. Now, as you can see, x1 stands for the first x-intercept, and x2 stands for the second x-intercept. Now, let's see this is what you're going to happen. X plus 2, x minus 6, because 2 is negative. So negative of that 2 and this negative, they give us positive, and 6 is, it will remain as negative 6. Now, we are looking for a this time. So in order for us to get a, then you have to look for a point on that curve, or that parabola, except these two x's, and then that point you can see we have negative, and there's a point which is y-intercept, where we have 0 is to what? 0 is to negative 12. We have 0 is to negative 12. That is y-intercept. Then we're going to use this point for x and y so that we can be able to determine what a. Let's substitute the value of y is negative 12, and then x is 0 and 0 you can see. Then you simplify it, that is going to be like this, and then you divide with negative 12, then the a is equal to 1. Then we have determined the value of what? A. Now, in order to get the value of b, then we have to come back to this page now. You can see this one. So instead of a, we just substitute with 1. So we cannot be able to write this one. Even if it's not there, it's fine. Then you open the bracket, apply a FOIL, you add the like terms. This is the equation of the graph. Now you can see the 12, the negative 12 that we have as a last term is there. And then now the coefficient of x, which is b, now you can see that b is equals to what? Negative 4. And then a is 1. So we have determined the value of a, which is equals to 1. We have also determined the value of b, which is negative 4. Determine the coordinates of the turning points. Determine the coordinates of the turning point. Now, if you have to determine the turning points of this parabola, and it is given in this form. Let me just show you something. it is given with f of x equals to ax squared plus bx plus c. If it is given in this form, and then we have to determine the turning point, then this is the formula that we are going to be using. Let me just remove this one and see if you can follow what I've tried to explain here. This is the formula that we're going to use in order to get the value of x of the turning point if it is given in this form. All right, then you can see we have just determined that, and the value of x of the turning point is positive 2. Then to get the y value, you're going to substitute this to original equation, and then where you see x, just substitute 2, then the answer is going to give us negative 16. That is the turning point. So the turning point now is what? Is 2 is to negative 16. You can please bear with me, this pen is not writing very well, but I hope you follow what I'm trying to explain to you. All right, now this last question, we have to sketch this graph now. We have to sketch the graph. Let me just clean my space. Let me clean my space before we can plot that graph of f. Let's see on how. All right, that is the graph that we've just drawn. You can see the turning point is negative 2. Is 2 is to negative 16, and the y-intercept there is negative 12, and both x-intercept, which is negative 2 and 6. And then we set a is positive, and then if a is greater than 0, remember the graph is facing up, and so that is the graph. So that is the parabola graph that we had to draw. All right, given f of x equals to negative into x minus 2 all squared plus 4. You can see there is a quadratic. That is a quadratic, the parabola graph. Determine the x-intercept of f. Now, if we are in need of x-intercept, we always know that we say y equals to 0. Where you see y, you substitute 0. Then, for you to get x-intercept, you can now open the bracket, apply FOIL, and add the like terms, and then this is what we're going to have as a standard form. Then you can see there is a common factor there, which is x. Thereafter, we can be able to solve the value of x. X equals to, the first x equals to 0, and the other x equals to positive 4. So we have just answered the question. And then we go to write the y-intercept. The y-intercept, if you want y-intercept, you let x to be 0. Where you see x, then you're going to be substituting with 0 there, where you see x. And then press your calculator, the y-intercept is 0. Write down the coordinates of the turning point. Now, for you to be able to get the turning point if it is given in this form, you don't have to use that formula we have used earlier on that said x equals to negative b over 2a. We don't have to calculate the turning point if it is in this form. All we have to do, you can see this is what? This is negative 2. If you take it to the point, it's going to be positive 2. That is the first value of the turning point, and then 4, we take it as it is, and then that is the turning point. I hope that's going to be the correct one. Yes, that is the turning point that we're having. All right. So it's much better if it is in this manner or this form, and then you have to calculate or you have to plot the graph. So there is no need for you to calculate the turning point. You just take, unlike that one where you have f of x equals to ax squared plus bx plus c, there you have to calculate first the x value of the turning point. Thereafter, you take that value that you have obtained, then you substitute to original equation to determine the y corresponding value for turning point. All right. All right. This one, first we have to sketch the graph. Remember, we are still on the same question that we just did now. We have to sketch it now because we have determined the x-intercept, y-intercept, the turning point. Now this is going to be the shape of the graph, and you can see the graph is facing down. That it tells you that the value of a is negative, is less than 0, and which is true. You can see it's -1 there, so a is less than 0, right? And the y-intercept, remember, it was 0, and then x-intercept we had 0 and +4. You can see that, right? Yeah, that is that. So that is the shape of the parabola. The last question, write down the range. Now, what is the range? The range is y is the element of, actually it's supposed to be negative infinity, not positive infinity. Negative infinity is to 4. So this is because this graph is going up, down, so it's going down there. So it's going to be negative infinity to +4. You can see that for us to determine the range for parabola graph, the turning point plays very important role, because we really need this value of y of the turning point so that we can be able to determine the range. Meaning, if we don't have the turning point, there's no way you can give us the range of that graph, quadratic or parabola. So turning point is very, very important, my dear learners. And then you can see with the square bracket. And remember, the infinity sign, it will always contain a round bracket. As you can see that it is a round bracket. And then this 4 is going to take square bracket y. It's not always in other functions that because there is a number there, you just put the square bracket. Let us understand why in some cases we put square bracket, in some cases we don't. Now, but as for parabola, it will always be a square bracket for this number, not for infinity sign. Infinity sign, I said you use the round bracket. Now, the reason why we say square bracket is because you can see the graph is turning exactly at +4 there. That's where the graph turns, right? So 4 is part of that. So hence we say square bracket. In the diagram below is the graph of parabola f of x equals to a into x minus p squared plus q. A hyperbola g of x equals to k over x plus a. A is 1:4 is the turning point of the parabola which intersect the axis at B and C. The y-intercept of the parabola is D, and therefore not D. Actually, it's supposed to be the y-intercept of parabola is E. Is E. There's supposed to be E there, and then D is x-intercept of hyperbola. You can see D is there. Is what is the x-intercept of hyperbola, and then E is what is the y-intercept of parabola. Now that is the graph that we are having. You can see we have parabola graph and hyperbola graph. Now let's answer the following question. Write down the coordinate of B. Let's go and look for B. You can see B is what? B is x-intercept of the parabola, and then we cannot say, let us determine B by substituting y with 0 because we don't have equation. But now the coordinates of C is 3:2, the coordinates of a turning point is 1:2. Now remember, there is a line that we call a line of symmetry that cuts this graph into two equal parts, and then this is 1 there. So meaning distance from here up to there is equals to distance from here up to there. So the distance are equal from this point to this and from this to that. So if we have moved from 1 to 3, how many units? It's 1, 2, right? And that's we end to 3, and then from there is 1, 2, meaning there this is going to must be -1. If that is the case, yes, the coordinate of b is -1 is to 0, right? So because we move 2 steps to reach 3, then we also have to move 2 steps to reach b, and then that value then is it gives us -1. Write down the values of p, q, n. Let's go for p. We can see the unit of p, and then we earlier on we remember when we explaining the effect of those parameters, we touched a p. Said p is horizontal shifting, and again p is the value of x on the turning point. Now you can see the value of x on the turning point is 1, so meaning p equals to -1. Remember, when you take it from the graph, you take it to the equation, it's going to change the sign. It's going to change the sign, right? And then what about q now? We are in q. We said q is the vertical shifting, and then again q is the value of y on the turning point. And what the value of the turning point there is 4. Hence we see q is 4. And then we have n there. Remember, we also explained the issue around m under hyperbola. We said is what is the vertical shifting, and again is horizontal asymptote. What is the horizontal asymptote? Equals to 1. You can see it's 1 there. So hence you see 1 there. So it's quite simple. That's why I did explain to you that it's very, very important to remember how to revise parameters, the effect of those. That is going to help you a lot. And then determine the equation of f. Where is f? Is 1. Let's determine that. Then we just substitute the value of p and q. You can see. And then in order for you to get a, we are looking for any point on the curve that you can use to determine a. Then we have taken this point, which is 3:0, point C. And then x is 0 and x is 3 there. Y is 0 and x is 3. Then just simplify this one and transpose 4 the side. And then this what we are having, you divide with 4, then you're going to have negative a. I mean -1. A is -1. And therefore this is the equation of f. That is the equation. Give the equation of x of symmetry for f. Now, if you are calculating or we are determining the equation of symmetry for parabola, you don't have to stress yourself. Just come inside the bracket, inside this bracket. What you see, x minus 1. Then you're going to equate this to 0. You're going to say x minus 1 equals to 0. You solve for x equals to 1. That is the equation of symmetry. You can see that this one. All right, is this line, and then you can see this line cuts x. This is +1. So meaning x equals to 1. And then please, if they ask you to give the equation of x of symmetry, or sometimes the equation of asymptote, don't just write the number there, because equation, it must have equal sign. You cannot just write the number and say that is, for instance, this one you say 1. You are not going to get it right, because that is not equation anymore. Equation should say y equals to this or x equals to that. All right. And then now determine the range. Determine what? The range. I mean, determine the equation of g. You want this equation. I think we're going to deal with that at the next slides. Let's address this one. we're still having the same scenario, same graph, but now we have to address this question that says determine the equation of what? Determine the equation of G. This one, let's determine that. Now remember, for n, we don't have to calculate. N is the horizontal asymptote, which is 1 in this case. That you can see there's 1 there. Now, in order for you to get k, we are looking for any point on that curve. The only point that we're having is this one, point D, on hyperbola curves, and then you're just going to substitute that point. So what is having, you transpose 1 to that side, with 1, and then you do cross multiply. 1 times k is k equals to -1 multiplied by -2 is +2. Then the value of k is +2. Therefore, the equation of G is this one. That is the equation of G. Sketch the graph of f of x. We have to sketch this graph. It's an exponential. Let's sketch the graph. This is the graph. We said very clear that if b is greater 1, this is going to be the shape of the exponential graph. All right, and then -1, the graph shifted downwards with 1 unit. Remember, original is supposed to cut y-axis at 1 here, and the fact that the graph shifted down with 1 unit, hence you can see it's passing through this point, 0 to 0, and then the asymptote, of course, is -1. Then you just so you can see this asymptote of this graph. So we have just determined the graph, determine the domain and the range of the graph. Now the domain is, it will always be x is the element of all real numbers. For exponentially, the domain, it will always be x is the element of all real numbers. So you don't have any, when you are dealing with the domain for exponential, just write x is the element of all real numbers, or you can also say x is the element of -infinity to +infinity. And then what about the range? Range is y is the element, supposed to be element in between. We don't have to write it y like it is. The way I did is very wrong. You just have to write y is the element of -1 to +infinity. Now you can see that for us to have range, what is important, you must know the value of the asymptote. Where does the graph cut? Where does the asymptote cut the graph on y-axis? It cuts at -1, and therefore the range is -1 to +infinity, because the graph, you can see, is going up there to what? It's going up there to +infinity. So it's approaching this -1, but it's going up to +infinity. So that is the range. Write down a new equation G if the graph of f moves 5 units up. Let's see the equation of a G. If it's moving up with 5 units, you just add with 5. And then our new equation now is going to be 2 to the power x plus 4. That is the new equation. Give the function defined by this, f of x equals to 2 to the power x, and g of x equals to -2 over x plus 1. Determine the coordinates of x-intercept of G. If we want the x-intercept, to let y equals to 0, and this is what we are going to have. Transpose, cross multiply, and the value of x equals to 2. That is what? That is the x-intercept. 2 y-intercept of this graph. Y-intercept, let x to be 0. Where you see x, you put 0, and then y-intercept equals to 1. That's correct. Number 3, equation of asymptotes for f and g. Remember, for f we have only one asymptote, which is moving horizontal, and that value is y equals to 0. That's number 1. For 2, the asymptote of G, we have 2. But this one of X, it will always be like this. X is equals to 0. It will never change. And then Y equals to 1. Y equals to 1. You can see, set this value, it gives us the horizontal asymptote. Sketch the graph of F and G on the same set of axes. Sketch the graph, and this is the graph. You can see this is what? This is the exponential one, exponential graph. And now this one, these two lines, these two curves, is for what? Is for hyperbola. Is for hyperbola network. So the red one is for exponential. So we did just draw the graph there. The graph below is given by f of x equals to ab plus q. The coordinates of b 0 to -2 lie on the line BC. The asymptote of f of x passes through b. The coordinates of a 0 to 1. Determine the value of a and b and q. A is this one, b is this one, q. You have to determine that. Now the value of q, we know that is the horizontal asymptote, and then b, we said b, the coordinate of b is this one. So therefore this is -2, hence q is -2, and therefore in order to get to a, you can substitute this point, point A, which is 0 to 1, and then A is equals to 1. And then B, what about B? Let's determine for B. We then substitute the value of B there. You transpose that one, and this is what we are having. Put square root, and then B equals to square root 2 square root of 3, and then that is that. So that is the value of B, that is the value of A, that is the value of Q. And then this one, determine the range of f of x. What is the range? We said for you to get the range of the exponential, it depends on the horizontal asymptote. The graph defined by f of x equals to a over x plus q is drawn below. The graph cuts the axis at -2. Make sure, yes, that's correct. The numerical value of q, we said is the horizontal asymptote. How much? It's +2. That's number one. And numerical value of a, for you to get a, since we have got q, we are looking for any point on that curve for x and y so that we can be able to get a. And then that point is -2 to 0, and then y is 0 there, -2. Transpose this to that side, then we cross multiply, and then it's going to give us a as +4. And then the equation of asymptote, y, x equals to 0 and y equals to 2. I said this one, it will always be x equals to 0, because in technical mathematics, we only focusing shifting the graph vertically, especially for hyperbola graph, not horizontal. The domain of this, x is the element of all real numbers, but x should not be equals to 0. This, even the domain of this one, it will always be like this. It will never change. Given the function defined by g of x equals to 1/2 x minus 4, and h of x equals to negative x minus 4. Is the g increase or decrease? Decreases, because now we can see if this is b is 1 over 2, so that it's going to take this direction. So exponential, if it's taking this direction, this graph is decreasing. It will only increase if it's moving in this direction. Can you understand that? So this, hence we say the graph decreases, and then write down the equation of asymptote of g, which is y equals to 4. That's number 1. This is equals to 4. Determine x and y intercept of g. Let's determine the x and y intercept. X-intercept, let y equals to 0. Then left from this what we have, and then you make the base to be the same. If the bases are the same, you then equate the exponent. And therefore, x equals to negative 2. That's number 1. And then y-intercept, you let x to be 0. Where you see x, you just substitute 0. Then the answer is going to be negative 3. The domain of h is the straight line, so it will always be x is the element of all real numbers, or you can say x is the element of negative infinity to positive infinity. The graph of a semicircle defined by h of x is this one. Sorry, let me just remove this. All right. Is defined by this centered at origin and exponential function defined by this graph diagram below. Determine the coordinate of a and b. You can see the coordinates of a and b are on the semicircle, but now if we can be able to know the distance of the radius, then we can be able to determine the coordinates. Let's see. The radius, the r squared equals to 4. What is the radius? If we put square root both sides, then it's going to be positive 2. Therefore, the coordinate of a is negative 2 is to 0, b is 2 is to 0. So those are the coordinates. Numerical value of q, which is the horizontal asymptote. Then we look for any point on this curve, and the only point that we have on this curve is this one, which is 0 is to 2. Substitute that value there, and then this what we're having, transpose 1, then the answer is going to be positive 1. The value of x for which g of x is less than h of x. Now, this g of x, it will only be less than h of x if it's below the graph of h of x. You can see the graph of g is only below from this point up to there. It's only below. So the graph of g of x is less than the graph of g of x from this point up to this one. So what is the value of x there? It's negative 73 over 50. What is the value of x there? It's 0. So it's between that and 0. Between negative 73 is to 50 is to 0. So hence we are saying that value of x is this one. So it's between. All right. And then what is the range? Remember, for you to get the range of this exponential, you have to know the asymptote. The asymptote meaning the value of what? The value of q. And we said the value of q in this case is 1. So let's see the range. Y is the element of 1, 2 is to positive infinity. You can see the graph is going up there. And the asymptote is going to pass through this point where it's y equals to 1 there. So that is the asymptote. So that's how you should determine the range. If you don't have asymptote, you can't get the range. So asymptote is very important. All right, thank you very much for being with me on this very interesting lesson. I hope everything that we have discussed today's lesson is going to help you for this coming final exam. And then let me just leave you with these words, and that says, our greatest weakness lies in giving up. The most certain ways to succeed is always to try just one more time. Don't give up. Don't give up, no matter what. Thank you very much. Have a nice evening. Bye.